So we've got this line, 2x minus 1, versus the sine function. And if you take a look at a sketch of the graph, so the sine function would go down to -1, go through the origin. Right about there would be pi. And then over here, when it hits the x-axis again, that's at 2 pi. So now take a look at this, which is a line. The slope is a +2, and then it's crossing the y-axis at -1. So down here is -1, and then make a straight line with a slope of about 2, and there's only going to be one place where it hits the sine graph. So now we need to show that that's going to be the only place. Since this is a trig function versus an algebraic function, then we don't have any exact methods to solve for x. We can show that there is one solution. So graph the sine of x and graph 2x minus 1. And so there's the value, so that's at, let's see, calculate the intersection. All right, so that's at, oh nice, at 0.888. X equals 0.888. So there, there is one solution. Now show that there aren't any others, that there's exactly one real root. And what I'm going to do in order to use the mean value theorem is, instead of having two functions, I need to have just one function. So I'm going to deal with the function y equals, and I'll just subtract sine x and put it on the other side. So of course when I subtract it, that would have left 0. So if we're looking at this function, then we're talking about when does that function equal 0? When does this function equal 0? So suppose that there were two answers. So suppose that the function is doing whatever. We have one answer at 0.888. So the function does whatever, and then suppose that it has to come back and hit the x-axis again. Well, then the mean value theorem, okay, here's a quick sketch of the mean value theorem. It says, suppose you have two different x values, a and b, and the function is at this height for a, and let's say that it's at this height for b. This is just a special case where the two values, the height is 0 and the height is 0. But the general mean value theorem says, okay, now suppose it's a continuous function. So no gaps or jumps or holes or asymptotes, just a nicely behaved function. Then it says, if you take the slope as you go straight from a to b, so that's just algebra, rise over run, find the slope of that red line. Then there's going to be a place when the function does this, there's going to be a place where the slope is the same for the tangent line. Like right there, or in this case also right there. So in our case, this special case, going between the two lines, the slope is equal to 0. That's a horizontal line. Which means that there's going to be some other place where it's got a horizontal tangent line, or in other words, the slope is equal to 0. So then there's going to be some value for x in between these other two where the derivative is equal to 0. Right there, the derivative would equal 0. So the slope is equal to 0. All right, go back to this and take the derivative. So it's going to be a 2. Derivative of that's 0. Derivative of that is cosine, so it's going to be a negative cosine. Set that equal to 0. And then move the cosine over. So cosine of x is equal to a 2, which is impossible because the biggest the cosine ever gets is 1. And so what I just showed you is actually called a proof by contradiction. You say, oh, you want me to prove that there's one of them? I'll assume that there's 2 of them. And then it turns out that that's impossible. So there can't be 2 of them. So there can only be 1 of them. So there is only one real root.